Displacement, it is a displacement means here the magnitude of displacement. It is the shortest distance between the initial and final position of the particle. Let x1 and x2 be the position of an object at time t1 and t2. Then its displacement in time interval delta t equals to t2 minus t1 is given by delta x equals to s2 minus x1, where x2 is the final position and x1 is the initial position. Or we can say that x2 is the position of particle at time t2 and x1 is the position of particle at time t1. Now from the above condition we can see that if x2 is greater than x1, delta x will be positive, and if x2 is less than x1, delta x is negative. If x2 equals to x1, then delta x equals to 0. Thus, it means that it may be positive, negative, or 0. It is a vector quantity. If we only say displacement, then it will be a vector quantity. That is displacement vector. The magnitude of displacement may or may not be equal to the path length traversed by an object. Its unit is meter, same as of distance, and dimension is L. In this example, you will see what is the difference between distance and displacement. Here, the same figure is shown as previous. A semicircular path followed by the body. Here distance is pi r. If body goes along ADB, in this case, and displacement is 2r, that is the shortest distance between A and B, that it represents the magnitude of displacement. If we ask displacement, then we have to say that 2r along AB. So magnitude distance is pi r, that is total path length, and displacement is the 2r, that is minimum distance between initial and final and initial position. So this is the difference between distance and displacement. Now we are going to talk about uniform motion. If an object moving along the straight line covers equal distance in equal interval of time, it is said to be in uniform motion along a straight line. Here the situation is shown. Consider A, B, C, D, E, F are different point representing different position, and the distance between A and B is 2 meter, B and C is 2 meter. That is, these divisions are equal. And consider body or particle moving from A to B in 2 seconds, also from B to C in 2 seconds, and C to D in 2 seconds, and D to E in 2 seconds, and E to F in 2 seconds, and F to G in 2 seconds, and body goes from A to G. Then the motion from A to G of the body will be called uniform motion, because in equal interval of time it travels equal distances. And from it is clear that why we tell this as a uniform motion. Now we are going to discuss about position time graph. The position is taken on the y-axis and the time is taken on the uh, mm, x-axis. Here a graph is drawn. What this shows that this line represent a collection of different points. For example, when the time is 0, the position of body is at 40 unit. It may be meter, kilometer, any unit you choose. For example, here I am choosing meter. Then body is at 40 meter from its reference point at 0 second. Similarly, after 10 seconds, it is also at 40 meter from reference point. That, and after 20 seconds, it means that on different time its position is same, that is position is not changing. This means that body is in rest. So we have written graph for the body at rest. If body is in rest, then the position time graph will be shown like as shown in the figure. And this graph shows the body moving with uniform motion. Body in uniform motion, yeah, uniform speed curves, may I say that. That is, here you see that after 2 seconds it travels 2 meter. After again 2 seconds, that is when it takes 4 seconds from origin. It again travels 4 meter, and it interval of 2 seconds it travels 2 meter. So this graph shows the uniform motion of the body. So the position time graph of a uniform body will be as shown in the figure. Now let's discuss about average velocity. It is defined as the change in position or it is defined as the change in position or displacement divided by the time interval in which the displacement occurs, and it is written as V average or average V equals to x2 minus x1 divided by t2 minus t1 delta x by delta t. This is the formula for average velocity. That is, we can say that average velocity can be defined as final position minus initial position divided by final time divide minus initial time, where x2 and x1 are the position of the particle at time t2 and t1 respectively. SI unit will be meter per second, dimension will be LT minus 1, and some important point, it is a vector quantity. Its values may be positive or negative. In position time graph, the slope of the graph is equal to the velocity of the particle. Here the position time graph of a velocity, positive velocity is shown, and we see that the graph is passing through the origin with fixed slope, and this represents positive velocity. Now it is a straight line showing negative velocity. If graph is as shown in this figure, then it will be a negative velocity, and if the graph is like this, then body will be in rest, that is position is not changing. In this case position is decreasing with respect to time, so the velocity is negative. In this case, position is increasing with respect to time, so this is positive. Hmm. Stabilize now.